We're going to be discussing about motion in a plane. Now, yesterday we discussed about motion in a straight line. What does that mean? We drew a straight line and then we talked about how someone could be in non-uniform acceleration. So when their acceleration is accelerating, and we solved for that equation using derivatives. Today, we're going to discuss motion in a 2D plane. Let's say we draw an x and y axis, which means the object can go up and forward. For example, when we throw a ball, it'll go like this, and then it'll eventually reach the ground. Now we're going to discuss about 2D motion. And our first topic is projectile motion, a form of motion that is projected in a gravitational field and moves along a curved path, a trajectory. What does that mean? A form of motion that is projected in a gravitational field. Earth. Earth is a gravitational field. And if we throw a ball, let's say this is our ocean and some planet or something. Trying to draw. So let's say someone was on top of here and they threw a ball. Now this ball would go up and it would come down because of gravity. Like if I clearly demonstrate it to you, this ball, let's say a ball was here, it'll go up and then after a certain point, it'll come down. Why? Because there is a gravitational force acting on this ball. Fg. F of gravitation, you could say. So, how does this work? Let's say we have an x-axis and a y-axis, and your projectile motion would look something like this. Let me just draw this a little bit right. So you can see it forms a curved path, like this. So your ball, it starts from here, and then it reaches a maximum height, and then it comes back down. This height, this length right here, this is going to be our maximum height, or h max. And you can see that this is being projected by some initial velocity. And this is going to be u because it's initial velocity. And using vector laws, this would be ux, and this would be uy. And this angle would be theta. It's the angle with which we're throwing the... Like, let's say some dude was here, and he has a ball, and he throws it like this. Then you can see it forms the same kind of vector law, and he threw it up with this angle theta. Now we're going to discuss more about this angle and maximum height and using vector laws to derive formulas for them. So, what do we do first? You could see that when this ball is going up, there is a velocity uy. But there is also a force pulling it down called mg. That is your gravitational force. So you know that F equals ma. So if you want to, we know that F equals ma. So if we want to find gravitational force, we have to use gravitational acceleration, which is mg. So your force of gravity would be mg. And you can see this force is constantly pulling it down till it reaches the bottom. So you could say that uy is being pulled down. Is being pulled down by mg. So it's not constant. Ui is always changing. But if we take a look at ux, so this is our projectile motion, and we can say that ui is not constant. But if we look at ux, there is no force opposing this motion. There is no force opposing this motion, except air resistance, but we're going to ignore that for this chapter. And another thing that has been proven is the time of ascent is equal to the time of descent. What does that mean? So after reaching this maximum point, the time that it takes to reach this maximum point is called the time of ascent. Time of ascent. And then the time taken to go all the way back down is called the time of descent. And time of ascent is always equal to time of descent. Now, we know that this is going to be uy. Let's say if this was some initial velocity u, this would be uy, and this would be ux. So, according to vector laws, if we have a vector here, and a vector here, and this is a vector, this would be a cosine of theta, and this would be a sine of theta. A sine of theta. So, using this, we can plot that down here. If this is u, then ux is going to be u cosine of theta, and uy is going to be u sine of theta. So ux equals u cosine of theta, and uy equals u sine of theta. Now, what can we do with this? So let's say we have some acceleration. If we take motion or velocity in the positive direction positive, or the upward direction positive, then we have to take force or velocity acting downwards as negative. So let's say we take uy positive. Let's say uy is positive. Then mg, or gravitational force, is negative. So let's do that here. You could do either one. You could take the upward direction negative and acceleration due to gravity positive. So ay would be negative g because we took it as negative, and uy would be positive, so it's just u sine of theta. And time is just t. Let's denote it by a capital T. Time equals t. And we know a formula, S. S equals ut plus half at squared. Using this formula, we can find S, or maximum height. Since Sy equals 0, we can derive a relation. Because why is it equal to 0? Because there is no displacement in the y-axis. So Sy is going to be equal to 0. And using this, we get uy t plus half ay t squared equals sy. And since sy is 0, we get uy t plus half ay t squared equals 0. Now, what is uy? Uy is u sine of theta t plus half negative g t squared equals 0. This is going to give us u sine of theta t minus half of gt squared equals 0, which means u sine of theta times t equals half gt squared. And if we divide by t on both sides, we'll just make it better, then these cancel out, giving us u sine of theta equals, this cancels out with 1t, half of gt. So 2u sine of theta equals, this is sine of theta, gt. So the total time taken, time of flight, is equal to 2u sine of theta over g. And this is how you get this relation. We we define initial velocity in the upward direction and the x-axis, and we define time. We know that displacement in the y direction is 0. We plug in the values and we solve for t. And we got this final relation, which is time of flight is equal to 2u sine of theta time over g. Now, half of the time of flight. Let's say your motion was like this. Now, this total time of flight taken, this would be equal to 2u sine of theta over g. Now, what about half of the time taken? That would be 2u sine of theta. That would be half of this. So these get canceled out, giving us u sine of theta over g. And what is half time of flight? So we know our full time of flight, total time of flight, equals 2u sine of theta over g. Or you could write u sine of theta as uy, initial velocity in the y-axis, and half time of flight is time of ascent, or the time it takes to get up here. Or, since this is also equal to time of descent, this would also be the time it takes to get back down from the maximum height. So time of ascent equals time of descent, which is equal to u sine of theta over g, or uy over g. So this is just something that you need to remember. Now, we're going to talk about the range of a projectile. What is range of a projectile? So we have an x-axis and a y-axis, and we have our projectile motion from here to here. Let me just draw that better. Now, what is range? This whole length that this ball traveled, let's say ball for now, this is going to be called a range. Now, how do we find the range of a projectile? So this would be your distance in the x-axis. So range is equal to x. And we also know that ux is constant. Means initial velocity in the x-axis is constant. And ux is equal to u cosine of theta. And distance, so we know speed equals distance over time. So distance equals speed into time, which means distance here is range. Let's denote it by x, or let's denote it by r, even better. R equals, speed is what? Speed is ux, speed in the x direction. So range would be equal to ux times t. Now what is ux? Ux is time of flight. T is time of flight. And ux is u cosine of theta. So let's substitute those. Ux is u cosine of theta. T And this would be u cosine of theta times 2u sine of theta over g. And simplifying this, we get r equals 2u squared sine of theta, cosine of theta. And there is a trig identity. This is 2 sine of theta cosine of theta. That is sine 2 theta. And this is g over g. So r, this is g, r is equal to u squared 2 sine of theta cosine of theta over g, which is equal to u squared sine 2 theta over g. And this is your final formula for range of a projectile. Now, how do we find maximum height of a projectile? So, let's take a 2-axis again, and this would be your projectile motion. Now, we need to find this height right here, maximum height. This point right here is called maximum height. And you could see that if your ball was here, the final velocity is 0. Why is that? Because it's starting to fall down and there is no movement at the maximum height. Like if I were to throw a ball vertically upward, there's a point where it would stop and start to come down. That point where it starts and stops to come down is your maximum height, and at that point, your final velocity is 0. So, how do we find the maximum height? This is your initial velocity, u, and this would be ux and uy, and your angle, theta. Now, we know uy equals u sine of theta. This u sine of theta. And the final velocity, so we're just going to consider this part of the motion. The final velocity is equal to final velocity of y, which is equal to 0. And ay is equal to negative g. Why is that? Because if we take this direction positive, then we have to take this direction negative. So ay equals negative g, and sy, the displacement in the y-axis, that is going to be h max, or your maximum height. And you can see we have a relation here already. We know that v squared minus u squared equals 2as. So let's substitute the values. V squared is vy squared minus u, let me use a different pen color. Vy squared minus uy squared equals 2 times ay times sy. So this is going to be vy is 0. So negative uy squared, negative of uy squared, equals, we know ay is negative g. So this is going to be negative 2g sy. And these minus get canceled out. So uy squared equals 2g sy. And what is uy and sy? Uy is u sine of theta full squared equals 2g, and sy is h max. Giving us, if we explain this, you would get u squared sine squared of theta equals 2g h max. And we divide by 2g on both sides. And these get canceled out, giving us h max equals u squared sine squared of theta over 2g. So this is your formula for maximum height at a point. So these are very important formulas you use for deriving relations between different parts like range and maximum height. So if I ask you to get a relation between range and maximum height, we would know that if sine 2 theta equals 1, then the range is maximum. Why is that? So we know that the range, the formula for range, is actually u squared sine squared 2 theta over g. Now, what is the maximum value of sine theta? We know that sine theta, no matter what this angle is, this could be 2 theta, 3 theta, um, n times theta, it doesn't matter. Whatever this is, sine of x is always between -1 and 1. So if the maximum value of sine of theta is 1, then your maximum range is equal to u squared over g. And that's just something that you need to remember. Now we're going to talk about equation of trajectory. We can see that your trajectory is in a parabolic shape like this. Let me draw this a bit better. So this is your trajectory. And you can see that this is a parabolic shape, which means it's following a curve of a downward parabola. And we know this is y equals negative x squared if we were using a standard parabola, but we're not. So we're going to derive the equation of trajectory. So this would be your maximum height. And position of an object over particular time is trajectory, which means if your object was here, now this would be your time axis, time, and this would be your position. Now, this is position over time. So that would be your trajectory, which means if you stopped time at this point, this would be your trajectory. So let's discuss more about that. We know that this is x, and this is y. So y is equal to x tan of theta, and this minus gx squared over 2 ux squared. And this is your equation of trajectory. Another thing is your range of two projectiles. Let's say two projectiles were thrown simultaneously. If the angles add up to 90 degrees, then their range would be equal. Like u squared sine of 60 degrees over g is equal to u squared sine of 30 degrees over g. And that's just something you need to remember. Now, we're going to talk about a horizontal projectile, and the time of flight necessary for that is t equals the square root of 2y over g. A horizontal projectile is where we're thrown, let's say, from a building, and it would come down like this. So that is your introduction to motion in a straight line. In the next chapter, we're going to talk about circular motion and circular dynamics, friction, and in math, we're going to talk about relations, sets and relations, or functions.